Hello, hi, Assalamualaikum. My name is Muhammad Fatur Rahman Birustam. I'm represent from our group, which is biometry is DE190162. I will explain about the 3.3.1, which is the open loop position control. Okay, first of all, the first step is we need to construct the block diagram in this figure by using the MATLAB Simulink. Okay, here the component and this is the parameter. Okay, so I will key in all parameter values in this Simulink block for this component for open loop position control. Okay, let's see. Okay, here we have the input angle, KP gain and actuator gain, electrical part which is the transfer function, mechanical part and integrator and the shaft motor position for display, and this is the input voltage. Okay, so now we go to next step is we need to check the Simulink by keying the input angle in value 1 and the gain value is 1. Okay, so this part for potential gain, input angle is 1 and the actuator gain is 1. Okay, let me see first. We set the 1, apply. Okay, and then actuator gain is 1. So we need to run. Okay, when we run, the display shown the input voltage and the shaft motor position is shown the result, which is the input voltage is 0.61 and then the shaft motor position is 11.73. Okay, so next we see the next step is we need, so the circle is function. Okay, function, and then the fourth step is increase step by step value of input angle from 0 till 10 and set the attenuator gain 0, and we will observe the shaft motor position display and what will happen to this system. So input angle 0 to 10. Input angle 0 to 10 is 0. Gain is set is 0. So firstly, okay, 0. We run. Okay, the result is 0 for the shaft motor position and we increase to 1. Fly, okay, and run. Still 0 in shaft motor position. We set to 2. We need to increase until 10. Still 0. Okay, 3. Run. Still 0. 4. Okay, still 0. And then we increase to 5. Okay, still 0. Next 6. Fly, okay, and run. Still 0. And then we go to 7. 7 for input angle. Still 0. Okay, next is 8. We need to do some until 10. Still 0. 9. Okay, 9 also 0. 0 value for shaft motor position. So lastly is 10 value for the input angle. Still 0. So can see that the system is not function. Okay, so next we go the step 5. Increase the 0 till 10 for the set input angle 0. Okay, from 0 to 10, set input angle is 0. Input angle is 0. Increase again until 10. Okay, 0 and observe the shaft motor position. 2. 0. 3. 4. 0. 5. 6. 7. 0. 8. 9. 10 lastly. Okay, so from 0 until 10, the shaft motor position is still 0. So next, the last step is the set input angle 5, 10, 360. Okay, and feed into the result. Okay, so firstly 5 for clockwise. 5 for clockwise. Input angle 5. Apply, and then the gain is 1. Okay, so this is the result for shaft motor position. We will record here. The input voltage we see the 3.056. Next is -5 for anti-clockwise. -5. Okay, here the result. So next is the 10 for clockwise, and the gain is 5. 10 5. So is 5 6.4 and this 6.11. Okay, 6.11. Anti-clockwise -10. Okay, and we run. So okay, see. So next is the 360. 360 for the 8. 360 8. Okay, so we run. Okay, here the result. So next the negative 360. Okay, so we record all the result in this table. Okay, for shaft motor position and the input voltage. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good evening. So my name is Muhammad Akmal bin Rizwan and my metric ID is AA190023. So for today I would like to execute the experiment number 8, which is the closed loop position control for subject BEV 30401 Power Engineering Laboratory 1. Okay, so for the closed loop position control, in order for us to execute the experiment, firstly we need to construct the block diagram in figure 3.5 by using the MATLAB Simulink. So, and then we must key in all the parameter value into the Simulink block. So I have prepared the block. So I prepared the block in the Simulink, and then we must check the block Simulink by put in the input angle value to 1 and the attenuator gain to value to 1. So if the input voltage and shaft motor position display show the value, this means the block diagram is function. So okay, we put the attenuator gain to 1. Okay, let me wait for 1. Okay, we put it attenuator gain to 1. And then the input is set to 1. Right. Okay, we put it to 1. Okay, and then we can run the simulation to see if the model is in function. Okay, we run the simulation first. Sorry for the inconvenience. Okay, so as you can see, the input voltage shows and the output voltage shows the value, and the shaft motor position shows the value. So it means that the block is in function. Okay, after we have checked if the block diagram is function, the next step is we must increase step by step the value of the input angle from 0 to 10 and set the attenuator gain to 0 to observe the shaft motor position display and to understand what is happening to the system. So we set up the attenuator gain to 0. Okay, we set up here to 0. Alright, and then we set up the input angle value to I put 10. Okay, 10 to see what happened. Can run the debug simulation. So as you can see, as the input angle is 10 and the attenuator gain is 0, we get the input voltage. However, the shaft motor position is 0 and the output voltage is 0. This means that the system is not functioning at this time because the attenuator is 0, thus not producing any output for the electrical part and the mechanical part. Okay, if we put here into, let's say I put 5, okay, input angle is 5, it will give the same result, I believe. Yeah, it still get the 0. So it means that whatever value we put here, if the attenuator gain is 0, the system will not execute the simulation, as the attenuator gain does not give any output for the electrical part and the mechanical part. Okay, after increasing the step-by-step value of input angle from 0 to 10 and set the attenuator gain to 0, now we try to do the same thing, except this time we set up the value of attenuator gain from 0 to 10, and then we set up the input angle to the 0 value. Okay, so let's see. Okay, so the input angle is 0. Okay, let's put here 0, and then the attenuator gain says to 0 to 1, and then we put here 1. Okay, and then we run the simulation. As you can see, there is no value that is you can get from the input voltage or the shaft motor position, as the input is 0, which means that the system cannot be executed. Okay, even if we put here 10, let's say we put here 10, the result, okay, if I put the attenuator again to 10, then we can observe the motor. It still gave the 0 for the output voltage, input voltage, and the shaft motor position. So this means that the input voltage, if the input angle is 0, so then the system will not be executed. Okay, so okay, so we done the step number 5, which is we set up the attenuator gain from 0 to 10 and set the input angle to 0. We move into the step number 6, which is to set the input angle to 5, 150 and 360. So we must put the positive signal sign for the potentiometer clockwise and negative for the anti-clockwise, and then we must fill in the table for the table 3.3. So firstly, we must set up the input angle to 5 first. Okay, we set up to 5, and then the attenuator gain, as you can see, is set up to 1 for this. For the input angle of 5, we set up to 1, and then we run the simulation. So the input voltage that we get is 3.056 and the shaft motor position is 3.927. Okay, if we change the angle to the negative, which is indicate that this is in the anti-clockwise. Okay, and then we run the simulation. We get the same value, except this time the input voltage have the negative sign and the shaft position motor have the negative sign. Okay, next we change the input angle to 150 positive for the clockwise, and then we change the attenuator gain to 5. Okay, we change it to 5, and then we run the simulation. We get the input voltage is 91.67 volt and the shaft motor position is 138.5. Okay, so if we change it to the negative to indicate that it is the anti-clockwise, it will get the same value, except each value for the input voltage have the negative signs and the shaft motor position have the negative signs. Okay, lastly, we must change the input angle to the 360, and then the attenuator gain to 8. So we run the simulation. We will get the input voltage is equal to 220 volt and the shaft motor position is 311.9. So if the angle is negative 360, which indicate it is the anti-clockwise, then we run the simulation. We it is still give us the same value as the positive one, except the input voltage have the negative 220 volt and the shaft motor position is negative 311.9. So that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.